Welcome to the second video in our high-speed subsystem video series, using HSSub apps for TPS development. To recap, an HSSub app is the software that controls the HSSub instruments, reconfigures test functionality, and provides programming API for test program development. The HSSub app is selected according to your specific test program requirements, and many different HSSub apps can run on a single HSSub reconfigurable instrument. Getting started with an HSSub app for your testing needs is easy. Just collect your digital interface test requirements, match them to an existing HSSub instrument, and then select from the available HSSub apps. These tables show the many available HSSub apps for TPS applications. Today, we'll highlight a specific use case that targets one or more of these existing HSSub apps. The HSSub apps are the main interface for the TPS to interact with the hardware. The HSSub app itself consists of a driver-like programming library for use in the TPS to configure and control the instruments, a firmware image to load on the instruments that conditions the I/O and performs low-level processing and protocols, and optionally a real-time image if the application requires it. The HSSub app interface provides a high-level API that aligns to the communication protocol or bus targeted in the application. For instance, the eDigital app, which performs low-voltage digital I/O testing, will have functions to configure digital test patterns, start the patterns, and evaluate results. The Ethernet Fixture Verify app provides functions to send and receive Ethernet message data. The HSSub app layer makes writing a high-speed communication test quick and easy without getting bogged down in packet information and hardware processing. In most cases, simply configure, send, receive, and validate. The process for using an HSSub app is like any other Ivy custom-specific instrument driver. You run the installer, review the provided documentation for the app, and then program the TPS using your selected C or .NET application programming interface. Underneath, the HSSub app is using the low-level Triflex subsystem driver to programmatically control the instruments. Let's run through an example. Say we need to test some UARTs on our unit under test. We can look at the existing HSSub instrumentation and see that the HSSub 9100 RS485 Foxy instrument has RS transceivers capable of RS422 and RS485. Checking our catalog of HSSub apps, we see that the RS app is provided with the Triflex installation, and this app provides virtual UART-style serial communication via these RS transceivers. We would then run through the documentation for the RS HSSub app, see the CAPI library, and walk through our test requirements to determine the necessary UART configuration. The app interface itself is easy to use. In our Visual Studio environment, we just add the appropriate libraries and include paths, and then start using the RS app API to write the test. Just like other automated test equipment, where we initialize a session, configure the instrument, and then generate or measure data, and then clean up and close the session, we follow the same steps with an HSSub app. Initializing the app creates the session with the hardware and loads the appropriate firmware for the app. We could initialize our UART on the HSSub Foxy instrument, register an event handler to read incoming data from the UUT, configure settings on the virtual UART, and then write data out to the UUT. After return data is received and processed, we would reset and close the virtual UART session. Our TPS is written and we are ready for testing. If we wanted to extend the capability of the Foxy RS485 instrument to something like validating the UUT data link with a pseudorandom binary sequence, we can integrate another app right within our TPS. The PRBS app is available for purchase and compatible with the HSSub 9100 instrument. We would just add a test, initialize a session with the PRBS app, configure and run the test, and then close that session before moving on to our RS app test. The flexibility of the Foxy instruments allows you to address multiple configuration requirements with one set of hardware and multiple apps. Other instruments like the eDigital or the LVTTL also support a handful of different apps to meet specific requirements. Evaluate your current and future needs. Select the set of hardware and software that meets those needs. and then write the tests in your development environment using HSSub apps.